Hello there. Welcome to this video. This is video number 2 in a series of 4 videos where we're going to be writing a password generation script. If you're new to this channel, what we're doing here is trying to learn Linux, specifically the Linux command line, and we are going to accomplish that by writing a series of scripts. Each iteration of the script will get more complicated, introducing new concepts and new commands. Along the way, we're going to write a README file where we are going to store these commands and concepts so that you can go back and reference them later until you feel comfortable with them and don't need to reference any further. Now, where we left off last time, I had you pin our terminal to the taskbar, so you should have it on your taskbar, whether that's on the side or the bottom. And again, if you didn't do that the last time, activities, you can type in terminal, open the terminal here, and once it's open, you would just right click on it and add to favorites, not remove from like you see here, but it would be add to favorites. So we're in our terminal. I like to go full screen, which is F11. And where we're going to start today is, let's start out with our README. And since we're going to be adding some new concepts in this video, I'd like to separate off the version 1 concepts from the version 2 concepts. And so let's put down version number 1 concepts. And let's make a divider. Remember, Control K cuts, Control U uncuts. And we're going to Control K 3 times and uncut to take that out of there. And we will uncut it at the bottom and change this to version 2 concepts. 2, 3, 4. So for this one, we're going to cover a couple commands and some concepts. So let's start out by copying out these concept syntaxes, or command syntax for this one. And we're just going to blank this out so we can repeat it a few times. And we'll go up here and get the same syntax for our concepts. Bring that down here and go ahead and blank this out. And we're going to do a command, and we're going to follow the command today with a concept, and then the concept will be followed with another concept, then another command. Just get ourselves set up here to make this faster later. And then after that command, we will have one more concept that we're going to track. All right, let's save that, and let's go to our first command notes here. And we'll get to what we are going to do first, and that's we're going to learn the command to copy files. And that command is the CP command, which CP is obviously short for copy. The syntax is CP, and you take the source file and you copy that to the destination file. An example of that would be CP password gen to password gen version 1. So you could make a backup of your script, and it should be noted that the CP command has many other options which we won't be covering here, but if you need to, you can always see man CP to look those up. So again, CP is the command, and it is CP source file to destination file. So let's go back out, exit this, which is Control O to save, Control X to exit. And let's make a copy of our version 1 script so that if anything goes wrong, we have a backup. So that would be CP password gen, and underscore version 1. Okay, now that we have a backup, we can go ahead and edit the one that we have to begin with. Before we do that, let's just run the script Remember, bash -n password gen will check syntax. Our syntax checks out, so we'll go ahead and take out that -n and call it. And there's our 16-character password that we left from the last time. It's got some numbers in it and lowercase letters. And in this one, we're going to start out by adding uppercase letters. So let's get in there and edit that script. And let's go back to the top of the script. First thing I want to do is, since this is version 2, let's change the version number and the version date, 319. And let's go down here. I would like to change these comments a little bit so that they match up a little better to what I said about using the variables in the comments. This is actually repeat until output password contains password length characters. And we're going to generate a random number, store, those look good. And this is the print final output password. And then I want to comment that other line as well. So let's go back up to here and add a comment. Should have done this the last time, and we're adding a new letter to our output password. So we said the last time that you could go ahead and just copy out these 26 letters, add them on to our case list here, changing those letters to uppercase. You'd have to then go up to shuffle, add 26 to the 36 to get 62, so we'd have the right number of random numbers that match up with our list here in this case statement. But this is already ugly enough. That just makes things even worse. You get into this gigantic case statement. So what we're going to do instead is we are going to leverage the bash parameter expansion I mentioned briefly in the last video. Now, we talked about how we can use these curly brackets to divide off a variable from any other string that it may be physically in contact with on the line there. And so that's how we're using it here. We're using the curly brackets simply to divide off output password from new letter. But we could make some additional changes here and leverage the bash parameter expansion to modify the value of new letter when it gets expanded and appended to output password. So to do that, what we're going to want to do is we want to go over here and we want to add an if statement. And what we'll do is, let's get a comment first. Add uppercase, no, not really uppercase new letter, right? Add a random uppercase letters. Syntax for if is if condition, then, and space these over because we're going to use this in our if condition. We're going to make this an if else. So if the condition is true, then we will execute the then statement. If the condition is not true, we will execute the else statement. And just like the case statement starts with case and ends with ESAC, which is case backwards, the if statement starts with if and ends with FI, which of course is just if backwards. So, condition. What condition are we going to use to get ourselves some random uppercase letters? Well, we're going to use a math comparison to do this. So that's double parentheses. And inside that math, we are going to do some math. But the math we do here, the value it returns, we want to have expanded so that it gets substituted into our mathematical comparison. And that expanded value is going to be compared to 0. So what are we doing in here? Well, we're going to take that rand number and we are going to determine whether or not the random number is even. If it's even, we'll raise it to uppercase. If the random number is odd, it will stay lowercase. And so how do we do that? Well, we're going to divide it by 2, but we're actually going to do modulus division. And so instead of substituting in the returned value for random number divided by 2, it's going to substitute in the remainder. When you do modulus, Bash will do the division and return the remainder. So in our case, if the number is even, the remainder will be 0. 0 will equal 0. Then we will execute the then statement. If the random number is odd, modulus will return 1. 1 does not equal 0, so we will execute the else statement. So what do we want to do in this part of the if conditions here? Well, we're adding uppercase new letter. And I mentioned we're going to wrap that inside curly brackets. And we need to add some syntax to erase this. So let's save this. And let's go back to the command line for a second. Clear the screen. We're just going to have a random variable x, and that's going to equal taco. If we echo $x, we get taco. $curly bracket x, we still get taco. But now, if we add some syntax after the variable, we can take action on that variable. So one action you might want to take is uppercase. And the syntax for that is Shift-6, or the up caret. And you'll see when we do that, it is expanded with a leading first character capitalized. And we talked very briefly about how Bash sees multiple of the syntax takes effect on the entire value, whereas a single of the syntax only takes effect on the first occurrence. So if we put 2 up carets in here, the word is raised completely to uppercase when it's expanded, and the single just forces the leading character to uppercase. But if x were already uppercase and you wanted to go lowercase, you'll see x is uppercase now, and if we put a comma in, again, single comma, takes effect on the first character, and so we get a lowercase t there, and 2 commas take effect on all characters, so we get a lowercase string. But what if that value for x contains characters other than letters? So what if x equaled 7 underscore tacos? So if we go back and we echo our x, you'll see 7 underscore tacos. If we raise that to uppercase for the single caret, up caret, that's going to take uppercase action on the first character of the expanded variable. In this case, that's the number 7, and you will see no action. Bash is smart enough to know that 7 is not a letter, so it can't raise it to uppercase, so it takes no action. Now what happens if we do 2 up carets? Well, that should affect the entire string, and you'll see that 7 and underscore are left alone because they're not letters, but tacos was completely raised to uppercase characters. So if we return to our script, we have new letter. New letter is only a single character, so we just need a Shift-6 one time, and our new letter will be raised to uppercase. So let's go back again to the command line. Let's clear the screen. Bash-n to check our syntax. Syntax looks good. And there you go. We've got some lowercase, uppercase, numbers. Everything looks good. So let's just put some additional notes in here real quick on this. Right? And shuff generates one number between 1 and 36, which that number is divided say modulus division by 2. If the remainder is 0, then the number is even, so make new letter, actually let's make the currently selected new letter uppercase. And just as a reminder, this has no effect on new letter if new letter is numeric. Okay, so we've successfully added uppercase letters without having to do a bunch of modification to our case statement or our shuffle command. But if you haven't already noticed, there's a pretty big problem with this, and that is the only letters that will ever be uppercase are going to be the letters that are referenced with an even number in our case statement. So Z will always be uppercase, Y will always be lowercase. So that's not really random. So what we need is a way to randomize this further. And so what we're going to do is we're going to introduce a new concept, and that new concept is functions. Now, when functions are executed in the shell that the bash script is running in, so they're essentially executed as if the code were occurring in line where you call it, but you need to make sure the function is declared prior to calling the function. So I like to put functions up at the top of the script. I like my common script declarations first, and then of course I love sections, so we're going to put a functions section in here. And we're going to call this function getNumber. Now, there's two ways you can declare this function. You can say function and getNumber, or you can do getNumber and double parentheses. Both are acceptable. The function getNumber is a little bit older, and generally the double parentheses is more the current way to call this, but either work the same. You just can't commingle the two. You can't do function getNumber double parentheses. And once you have declared the function, you need an opening curly bracket and a closing curly bracket, but I prefer to put my curly brackets on separate lines. And then since this is executable code, I like to go in 4 spaces, so we'll indent 4 spaces. But before we do all of that, anytime you define a function, it's a good idea to put some kind of notes with that function, similar to our comments. And so what I like to do is a little usage and some additional information. So first of all, usage getNumber. We're going to put a bunch of comments in here. The first thing we're going to do is input. Does the function take any input? Then output. Does the function generate output? Returns. If the function returns to the script, what do the return codes mean? And lastly, notes. Do we have any notes on this function? So of course, since we're just writing this function initially, we don't know the answers to these questions, so we're going to hold off on that for now. But I am going to say that we're going to do 2 functions in this script today. So let's go ahead and cut these and uncut them, so we have this ready for our later function. Okay, so what are we putting in this getNumber? What we're going to do is we're going to go down here to our shuffle command that we're using inside the rand number definition, and we are going to move this syntax out of here. Now, as I said before, Control K cuts a line, and Control U uncuts a line, but you can also just cut a string of text, and the way that's done is Control Shift 6 and then take the cursor all the way over to one character past what you're looking for to cut, and then again it's just Control K removes it. And if we go back up here to get number and we uncut it, you'll see we paste that right back in our function. Okay, so let's look at these parameters. Input. Well, the function takes no input. Output. This prints to standard out. And it's a good idea to say what the expectation of the print is. And so in this case, it prints an integer, right? It prints the single integer generated by shuffle. There's no special returns to be of note, and there's also no notes. So it's pretty straightforward. If you come up here, you look at the syntax, you just call get number. There's no input required. It prints to standard out. The thing that it prints to standard out is an integer. There's no return codes to be concerned with, and there's no additional notes. So we've got a function and we've got some well-defined notes on it. So let's go back down here and we're going to put that function back in where we took it from. So get number. Now, when we call get number, you'll see that I don't put the double parentheses after it, which is common in most scripting languages, but this one, Bash doesn't do that. You just call the name of the function. So in this case, we call get number. So if we've done everything right, all we've done is move this code up. Our function should still work the way it did before. So let's clear the screen. Let's check our syntax. Syntax looks good. Let's run our function. Uppercase, lowercase, numbers. Very good. So what does this do for us? We just took a line of code and we moved it up someplace else in the script. Well, what this does is we now have a common command that we can run multiple times without having to rewrite all of the syntax, which is nice because if you decide to change the syntax, you only have to change it in that one place. And the way we're going to use that is we're going to replace our rand number with a call to our get number. And again, we're executing a command in a subshell here, and we're expanding the return value to be used inside of this equation. We're then doing a modulus 2 to determine even or odd, and if the remainder is 0, it's even, and if the remainder is 1, it's odd. If it's even, we go to then, we raise the new letter to uppercase. If it's odd, we just use the existing new letter, and no effect on numeric. That should effectively change how we pick our upper and lowercase letters and make it pseudo-random as best we can. So let's check it again. And you see we're just getting a mix, upper, lower, but now we're not stuck to having the even number definitions of new letter always be uppercase. So that's good. We've added some additional syntax to our code, added a function to our code, leveraged bash parameter expansion. But let's make this script a little bit more interactive. Right now, our script can only generate a hard-coded password length of 16 characters. What we need to do is add an option so that this password length can be passed at the command line when we call the script. And so what we're going to do first is I'm going to create yet another section, and we're going to call this section CLI, command line interface arguments. And I'm going to go in 2 spaces here. My definitions are 2 spaces in, and my executables are 4 spaces in. And so what do we want to do? How's this going to work? How do we get an argument from the command line into our script and reference it. Well, let's go back to the top of the script and look at something real quick. So I mentioned positional parameters when we did this prog name equals 0 definition. And I said if on the command line you call password gen, that will be stored in Bash's built-in variable 0, and you can reference that with $0. Well, in the same way, we could have arg1, arg2, all the way up to argn. And this again would be stored in 1, 2, and in n. And if n was 2 digits, so it was greater than 9, it would be nn. And the way we would refer to these is $1, $2, and curly bracket and n. It has to be curly bracket because if that number was, if it was the 10th positional parameter and you did $10, Bash is going to see $1 as this $1, and then it's going to have this 0 over here that it doesn't know what to do with. So by putting it inside the curly brackets, you'll see that it all becomes together as argument number 10. So how does this help us? Well, if this were our password length, then our $0 would be password gen as it was called from the command line, and our password length would be passed into our $1 or our variable 1, which we reference as $1. So that means that our CLI arguments, we could take our password length and set that equal to $1, which means we can take this from here and we can remove that comment because you don't have to change the password length in the script anymore. It will come in from the command line. So let's take a look at that again. Check our syntax. Syntax looks good. Generate our password. Let's give it 16 characters. Let's give it 6 characters. Now let's give it 116 characters. Oh, well, Bash did it, so that took a little while, but it did generate a 116 character password. Now, it's probably not something we want to normally do, so anytime you take an argument in from the user, you should validate that argument, and that's why we have this CLI section. We want to make sure that our password length is something sensible. So this is where we can kind of set a minimum and maximum password length, right? And what we do is we'll do another if statement with some kind of math condition here. And if the math condition matches up to what we want, then we will assign password length. If it doesn't, we're going to want to echo some kind of error message. And then we're going to want to exit our script. So what do we want to look at here? Well, we want to take that $1 and we want to figure out if it's at least 8 characters long, so it has to be greater than or equal to 8 characters. But we also want to make sure that same $1 is less than or equal to, let's say, 24 characters. And the way we combine these two statements is between them, we use a double ampersand. A double ampersand means and. So if this condition is true and this condition is true, then assign password length. Else, or otherwise, echo this message and exit our script. Now you could also do one or the other condition, and that would be two straight pipes, and that would be the or. So if this is true or this is true, then assign password length. Now in this scenario, If the first one is true, it does not even make the second comparison. If the first one is false, then it goes to the second comparison. In this scenario, with the double ampersand, our AND scenario, if the first condition is false, then it doesn't bother to check the second condition. It knows that both of these have to be true. So if this is true and this is true, we get our password length. So let's go back again and just take a look at that. Syntax looks good. Let's go 8 characters. That's good. 18 characters. That's good. 118 characters. Error message. Okay. What about 1 character? Error message. All right. So the script did what we wanted it to. We want to probably clean this error message up a little bit because that's not really telling the user very much. I like to put my error messages inside of double asterisks. And what we're going to say here is invalid value for password length. And then I like to repeat back the value that was passed so that when it prints to the screen, the user can see exactly what it was that they passed that doesn't work. And if you just see that again, invalid value for password length, and then we get the 1, which indicates that you passed a value of 1, which was no good, or 118, which was no good, but with 11, we generate our password. So, 2 things on exiting on error. First of all, since this is an error message, we want to send this to the error file descriptor. We talked last time that the error file descriptor is 2. And we want to send this output to that file descriptor. Well, last time we just looked at taking the output and sending it to some kind of file. This time, we want to take our standard output that echo creates, which is 1, and we want to send that to 2. However, in this syntax, this will take standard output and send it to a file named 2. So what we need to do here is we need to put an ampersand in, and this ampersand tells Bash that when you're sending this output somewhere, instead of sending it to a file, redirect it to standard error. And also, again, the 1 is assumed, so we don't need to put that there. So now when this message is echoed to the screen, since it's an error message, it will print to standard error. The other thing we want to look at is, since we are exiting on an error condition, we want to go ahead and exit with an error code greater than 0. Bash sees error codes of 0 as a successful completion of a command, and anything non-0 as a failed completion of the command. So we're just going to go ahead and exit 1. And let's go back to the command line and see what that does. So if we check our syntax, it's good. And let's go just 8 characters. That works. We do our 118 characters, and you'll see we have invalid value for password length. And my command prompt has the last error code expanded in those curly brackets. Yours is probably default and won't have that, but the way you could check this is you could echo, and Bash has a built-in variable for the last error code from the last command, and that would be question mark. And of course, to reference any kind of a built-in variable or any variable, you got to precede that with a $sign, and you will see there we get our 1 that we exited with. Now the next thing is, what about that redirecting to standard error? Well, in this scenario, if we were to take the output from the script, the standard error stream, we could write that to a file. Linux has a file called dev null, which is called the bit bucket. Essentially, it's just a trash can for data. So what we've done here is told Bash that when password gen spits out output, any output that comes out for standard error should be sent to dev null instead of to the screen. And you'll see we still get an error code of 1, but now there's no data there along with it. We've lost that message, and that's because it's been redirected to a file. It doesn't seem handy, but if you had some kind of a script and you wanted to write to an error file, you could do that. Or if the script might have output that was both error and standard error and standard out, we could redirect to progname .log for all of our standard out messages and progname.error for our standard error messages. So you see here we're just taking that standard out stream, which this is a 1, writing anything that comes out from that to progname.log, and 2, writing anything that comes from the standard error stream out to progname.error. So it allows us to divide up our log messages from our error messages. Quite useful. But in our case, we just want to make sure that we're writing error messages to the correct file descriptor, and we're exiting with the correct exit code. There are a number of exit codes. Some of them are built in and reserved. Others are available for various purposes. The easiest thing to do within the scope of what we're talking about is exit 1 to indicate that we did not exit on success, but we exit on failure. So this is good. We've done something pretty nice here. Our script now is a little bit more interactive, and we're validating user input. Let's just try one other thing though. What happens if we don't pass a value? Well, we got some weird results there, right? We got an error on line 66, and we got our message. So what happened? Well, we didn't pass a value for $1, so nothing was substituted here, causing Bash to spit out an error for bad substitution, and then we went to the else. We echoed our message, we exited 1. So we need some other additional checks, and we're going to come back to a bit of a better way to do the CLI parsing that is a little more consistent and gives you a little bit more power. But first, let's go ahead and create another function. And for this function, what we're going to do is we're going to create a function that helps us tell the user how to use our script. You know, right now we know that if you pass the password length to this script when you call it, that password length will be used and it will be generated as long as the password length is between 8 and 24. But there's no way for the user to know that. And how does the user know where to pass the variable? Is there any kind of syntax specific to passing that password length? So that gets into creating a help function. So our help function, I like to use the name script usage. And we're going to call this script usage. Open and close curly brackets. And we're going to be echoing a bunch of things here. So 4 spaces and echo. And let's just put a couple of them in there. I like to echo with a leading blank line. Makes it easier to read. And so what are we going to write here? Well, this is going to be a usage message. And now that progname variable that we stored before comes in handy. And then we tell the user give us your password length. Additionally, we need to tell the user that that password length has constraints, and let's see, must be an wrong one there, must be an integer between between 8 and 24. I also like to follow with the blank line, so we'll put an echo there. And at this point, since we're printing our usage, we would want to exit. Okay. So how do we use it? Well, what we can do is we can go down here, take out our exit statement, and call our script usage statement instead. Now see I've left this 1. Just like calling the script from the command line with positional parameters, you can also call functions with positional parameter, and in this case, this value, in our case 1, would be passed to the function as the first positional argument, or $1. So we can put that here after this exit, and whatever exit code is passed when the function is called will be passed to our exit statement. So that means that the input our script has is an exit code. Now I like to do this. I like to put that exit code in here like this. That's how it would be called in most languages. Now of course in Bash, really the correct usage would be this way without the parentheses, but I think it reads a little easier like that. Now our exit code has some constraints, right? This has to be an integer. And what about our output? Well, we're printing to standard out. And what are we printing? Well, this is a message string. What does it return? Well, it doesn't return, so it returns none. And any kind of notes? Well, it always exits. It's important to note that, since you want to make sure that anybody reading the script realizes that when we call this function, you're going to leave the script. So let's go back down here and see what we've got. We check our length. If the length is no good, we echo a message, and it should tell the user a little bit more information. So let's go back and do that. Let's do a syntax check. All good. Let's add in an invalid length. We get our invalid value for password message with the value passed, and then we get our usage message. Usage, password gen, password length. You see there, now the user knows the first positional parameter has to be the length, and it must be an integer between 8 and 24. So that's good. Now when we have an error, the user can get some more information on how to call the script. But how does the user ask the script for help to begin with? Well, that's something that we need to add in. So let's go back into our script and look at that. We could change this if statement to an else if statement, which in Bash is referred to as elif. And we could put an if here and some kind of help condition. And then we would have our then statement, and we'd use our script usage. And we would tell it to just exit normally. And that would work great. We come up with a good help condition for what we're looking for, and that would work just fine. But then if you want to add a version number, if you want to add anything else, you keep adding on to these if statements more and more, and it gets pretty long. And like I said before, if statements aren't the greatest way to execute in a Bash shell, and additionally, it just gets ugly. So instead, we're going to introduce a new concept. Before we do that, though, get too far ahead of ourselves, let's suspend this and nano our README file. We've got our CP command there. Let's go down here and put in some notes on our positional parameters. And script and function positional parameters. An example of that would be my script.sh arg1, arg2, dot, 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 argn. And notes on this inside the script or function. Nope, that's not right. These are referenced as arg1 becomes $1 all the way up to argn becomes $n. And just remember, arg10 and above, use the dollar curly bracket NN referencing. So those are some good notes on our positional parameters. Let's go over here and also keep track of that file descriptor redirection we did for our error statement. And just lengthen our divider here. And so what did we do? We did a standard error redirection. An example of that was just like the example we used before, where we had a command writing an error message, and we do the redirection syntax, which is open angle bracket &2. That sends it to standard error. And just as the notes here, message written by the command will be redirected to standard error instead of standard out. All right, good. So we're moving along nicely. 3 of the 5 things I mentioned that we're going to talk about we've got covered here. So Control O to save, Control X to get back out, and we're going to do FG to get back into our suspended script. And so that brings us to our next concept command, and that is going to be getopts. Now, getopts is a bash built-in, not to be confused for getopt, which is a different command. But our getopts allows us to parse command line arguments. And the way that does this is through the use of an opt, string of some sort, and a variable. So we pass it a formatted opt string, which we'll get to, and we give it a variable to work with, and getopts will parse our command line arguments. Now the way we use this is we use this as a condition inside of a while loop. So while getopts is doing its thing, we want to do what we have down here, and any of our loops that start with do end with done. Okay. So what about this opt string and this variable? Well, let me give you the easy one first. I like to use OPT for opt. You could be, it can be anything you want that's not a built-in or not used in your script. I like to use short lowercase variables for these kind of throwaway variables. And in this case, the only place we're going to use this opt variable is right here, and it will be done for after we leave the CLI arguments. So I opt for opt. Now, this opt string. This opt string tells getopts how to behave, what to do, what to look for. And the way that works is you put in the flags or switches or parameters you're looking to pass from the command line and list them here in our opt string, and then you give getopts some additional detail. So, for example, our password gen. and we're calling that with password length right now. GetOps is looking for some kind of flag, and so what if we gave this the -L for length flag? Down here, you leave off the dash, you tell getOps, hey, I might see -L on the command line, so be prepared to parse that. Okay, so what happens when we get that -L? What do we do with it? Well, we need to create a case statement to look at what value is stored in the opt variable. So case in, and we close our case statement with an ESAC, and we are looking for an L to be passed. And if we get that L, we want to go ahead and use this syntax that we've already defined to verify the password length. So we'll indent these over to line everything up. And of course, we got to close the case list with a double semicolon. And so now when we pass password gen, this -L flag, it will be parsed by getOps. It'll see the -L, and it will push some values into, it'll push a value into opt, and we can go down here. Opt would have that L, and we would execute these commands. But is it still $1, right? I mean, this is 0, so this is 1, so this is 2. So we need to go down here and change this to 2. Well, no, not exactly. What you need to do first is you need to tell getOps that, hey, this -L flag, it has a required argument, and you do that by putting a colon after the L. So you're telling getOps, when you see this L, there's supposed to be something after it. So what will happen now is that L will get passed to the opt variable, and this value for password length will be stored in a built-in variable called opt_arg. That opt_arg replaces these positional parameters. So every place we're referencing that $1, we put opt_arg instead. So cover it again, right? Password gen's called. We have the -L option with an argument of password length passed after it. getOps sees that L and recognizes that it has a required argument to go along with it, so it stores the L in opt. We do a case comparison for opt to L, and then we can parse the rest of this just like we did before. So let's see how it works. Syntax looks good. -L, 16 characters. Hey, 16 character password, 18 character password, 118 character password, invalid length. We get our message. Everything looks good. But what happens if we forget to pass an argument to -L? Well, we got a message here that we didn't generate. It says password gen option requires an argument, L, and then we get an error on line 115. So let's go back in and look at what happened there. First of all, let's go to line 115. In Nano, to get to a line, Control-Shift_, and then the line number, 115. And you'll see it's the password length line. And of course, since a value was never stored here, when it got to this line in the code, it was an error and bash bailed. Well, that's because we never got this colon argument here stored into opt_arg. So password length was never set. But that raises the question, if that's the case, why didn't the error occur on this line? If these were blank, we would have gotten an error. So why didn't we get an error for that one? Well, that's because the way we are running getOps right now is we are letting getOps handle errors, and we are then parsing the rest of the arguments ourselves. So what do? Well, one option would be to put a default statement in here. The default case statement is just asterisk, parenthesis, right? And then what would we do? We'd echo some kind of error. We'd send that to 2, and we would script usage here, and let's see what happens. Syntax is good. Let's give it a valid one first. Okay, we know it works. Give it a bad one. Password gen option requires an argument. Same error message we got before. Then you see our error message printed. And then line 50, exit password gen requires, oh, well, that's a different mistake. I know what we did wrong there. So we'll come back to that one. But in any event, our error message printed, our usage message printed, but we also got this password gen error message that was printed by getOps. So the default statement, it works, but you still get some barking from getOps, and it's not all that clean. Now that error message that we got is because I forgot to put a 1 here. And this is line 50. Control C to check line number. Oh, yeah, no. Line 50 is the exit from our script usage function. So we're going to touch back on that, how to deal with that problem in a minute, but let's finish here with this. So what's our choice if we don't want to let getOps? Is there a way to not have getOps do error message handling for us and for us to work it out on our own? Well, there is. And the way you do that is you enable silent reporting by having the first character in your op string be a colon. getOps loves the colons, but by doing this, you're telling getOps silent error reporting. So don't print any error messages. And when you do this, getOps does something kind of interesting. Instead of using this default statement, getOps introduces 2 new values that it will store into opt. The first value is a question mark, and the second is a colon. GetOps and the colons, they love the colons. So what do these mean? Well, the question mark indicates that an option you passed was invalid, right? And so that would be an invalid option. And I like to print that option out here. We'll get that in a second. The colon indicates a different error. And what that indicates is that we are missing a required argument. And that required argument was for something. Well, what are these somethings? Well, in this case, and actually in both cases, getOps assigned this question mark to the opt variable and this colon to the opt variable. The invalid option that was passed is assigned to opt_arg. And the flag with the missing argument is also assigned to opt_arg. So now we get more specific error handling based on whether you pass something that was invalid or you pass something that had required arguments and you just missed it. So are we ready to test? Well, not quite. There's one other thing we have to do, and that is because the case statement is looking for patterns. Look at this, I'm off by a character. This question mark is seen as matching any single character. And so what we have to do is we have to precede this with a forward slash or whack, which essentially is just an escape character that tells the case statement, hey, this isn't a pattern. I want you to find specifically a question mark for this match. And in doing so, getOps will pass the question mark to opt for us, and then we will match at this portion of our case statement. So if that's all correct, we should be in good shape here. Syntax looks good. Dash length 16, 24, 32, invalid value for password, which is our error message, and you see our usage statement. If we forget to put it at all, there's our missing a required argument for L, and then our usage statement, which is wrong. We need to correct that. We'll get that when we go back in. And what happens if you pass an option that's invalid, like -T? Well, now it says invalid option and our usage statement. One thing I would like to point out here, we just rerun that one. That redirection that we were doing, to see that in action, the usage portion of this statement is printed to standard output, but that invalid option is printed to standard error. So if we take that standard error file descriptor and send that to that bitbucket dev null, anything printed to standard error should disappear. Anything printed to standard out should be printed. And that's exactly what happened. We could reverse that and redirect standard out and allow standard error. And you see we get that. So there's the power of those redirections and those file descriptors. So it really allows you to move the data around, and if you format the data correctly in your script, it gives the user the option to move that data around. So let's go back. We mentioned that we had to update our script usage, and what we need to do is we need to put this -L flag in here. Now, one thing to note, I'm using these closed and open angle brackets. This indicates that the value is required. If this were an optional value, you would instead put that inside of square brackets. Square brackets indicates optional, whereas the angle brackets generally indicates required. All right. So we're going to go back down here real quick to our CLI, look at what we've got. We've got some nice error handling here. We have some validation for the values being passed from the command line. So we're looking pretty good, right? Well, if that's the case, let's go back out and do another test. First of all, what happens when we just run it incorrectly again? Invalid option for T. Now our message is the way we want it. Things look good. What happens if we pass it the right value? We get our password. What happens if we pass it nothing? Well, now we got some kind of error. So what happened? We go back into our script. Let's go to line 123. And you'll see that again, password length wasn't there and became an issue. So why is that? Well, our statement up here is checking that L. If we get a valid value, it's comparing it to our limits, setting the value or exiting, and then we're also handling missing arguments and invalid arguments, but there's nothing here that prevents the required value from being passed, not being passed, and then exiting the script. So what we need to do is an additional check here. And that additional check is to make sure before we leave the CLI argument section that we got all of the required parameters we were expecting. So let's do another case statement. And in this instance, what we want to do is we want to just verify required, probably need that cue, flags, or arguments. And we're going to use a case statement, and we're going to look at that password length variable. I'm going to compare it against some kind of list and close our case statement. So what are we going to compare this against? I mean, do we compare it against all numbers between 8 and 24? You know, that's not really going to work out too well. We're going to get a nice, long, messy situation there. And so the answer to this is, again, to go to Bash's parameter expansion. Now, there's two ways to go about this. So first of all, let's introduce the new parameter expansions. We have two kinds, okay? Variable that is set or has a value, and a variable that is not set. When a variable is set and you pass it colon plus, Bash will complete some kind of substitution here upon expansion. On the variable that's not set, colon minus will trigger that substitution. Let's go back to the command line again, and let's check what we have in X. So we have some kind of value, so it's set. So we take that X and we expand, and let's replace it with set. So what are we doing? Well, if X has a value set to it, or the variable is set, then substitute whatever that value is for this string that we have put on the end here, and the string is set. Well, there you go. Well, what happens if we unset X and do the same thing? Nothing. Nothing at all, because the value is unset. But in this case, if we were to use the colon minus and substitute in unset, we get our value back. So this is handy for checking variables and then validating that you're getting what you're expecting. And so what we can do, we can either see if this is unset and do something with it, or in this case, I like to see if it is set. And if it is, I like to compare it to set. And then something has to happen, right? And then if not, the default is going to be to echo some kind of error to standard error and call our script usage function again. And exit the script there. Well, let's start with this. What do we want to do here? Well, we don't want to do anything. This is effectively just a whitelist. So what I like to do is just put a comment, nothing to see here. If the variable's set, case will match the set string we've put there, and we're good to go. Anything else results in us printing an error message. And in that case, we are missing the required password length parameter. So what do we get? If we've successfully matched up here on what we're looking for as far as restrictions, the value is stored in password length. When we get to our case statement, password length is set. We match this whitelist. Everything's fine. If it isn't, we'll get this error message. So let's go test that. Syntax looks good. Let's give it a valid value. That's good. Missing an argument for L. Missing required password length parameter. So we've got, again, our usage statement there, but we've also got that password parameter indication for us. So now we don't exit later in the script on error because we've caught that error before it happens. So this is good. We're in good shape here. One thing to point out, you see up here I'm using L without double quotes, the question mark without double quotes, the colon without double quotes. Case is matching some kind of pattern here, which is a little bit confusing. It's not an actual direct match to a value, it's a match to a pattern, and it's not a regular expression, which is definitely outside of the scope of this. But you just need to know that it's pattern matching. And so generally what I do is if we're just matching a single character, I don't concern myself whether or not that is a stringed character or patterned character, because it's either going to match or it's not. But once we get outside of a single character, I prefer to put those in quotes to make sure you're matching the string and not some kind of a pattern. Just personal preference. This would work just like that. So you could have set without the double quotes around it and it would be just fine. All right, so looking good, right? Well, one other thing we should do is give the user the option to ask for help before they exit the script so that they can avoid the error message. And what we'll do is we'll add a -h flag. So let's go up here. And update that -h by itself. Print this help message. Now you notice I'm not going to add up here that this is an optional -h, and I'm doing that because it's not optional to the way the script runs. It's just something that you can pass to get help, but it doesn't change the way the script works. In our next version, we're going to cover options at the command line like this, where some of the arguments are required and some of them are optional, and you'll see that in use there. But for this one, we're not going to do that, and we're going to leave that as it is. And down here in the opt string, I added in our h. There's no colon after it, so it's not looking for an additional argument. We'll put our h in here. And all we're going to do here is call script usage and pass a 0. So now our user should be able to ask the script for help before they call it. And there it is. Exit code is 0. You could again check that with $question mark. We get a nice clean help message. It didn't print any kind of an error message. And if we were to redirect that output to dev null again, the bit bucket, there's no error message, so we didn't get anything because everything was printed as standard out. It's a good shape. So we've got our help, we've got our length requirement, we've got our validation for the correct length, and we've got our validation that the required values are there. A couple other things I'd like to touch on. I'd like to go over some additional parameter expansions while we're in this script. And so the first one I want to touch on relates to an error we had earlier, and that was earlier I failed to pass a value for the exit code, and we got an error message on this line that said it required a numeric value. So again, we can leverage parameter expansion, and what we can do is, in this case, we are looking for, if it's unset, substitute a value, and the value we're going to substitute would be 0. Now, of course, that makes this exit code become optional. But again, if we get here and the first argument passed to the function is not set, we are going to get 0 substituted in place for it. And if we go back down here, and let's take this out. Since 0 is the default condition, there's no reason to pass a 0 to the script usage. All these other ones that require a 1 for their error messaging would stay there. However, if for some reason we forgot it, the script wouldn't error out. We do have that error protected. So let's just see that real quick in action, and you'll see that there was no errors. We got that 0 substituted in, even though we left off argument 1 here when we called this function. So next thing I want to touch on is this prog name $0. We're going to do some even fancier parameter expansion here. And first, let's make a point of why we would want to do that. So we have our script. We called bash password gen, usage password gen, everything lines up. Well, if we pass // for executing it from this directory, / is just a path to the script, and dot is current directory, so / tells it using the current directory. That's where this password gen should be located. Go ahead and execute that. Well, now / is in our password gen. Okay. Well, this is also located in /home/bashed. So now, if we call it that way, we've got /home/bashed/password gen, or // or you could even go back 2 directories. Either way, what you see here is that each one of these is called differently, and the usage message then prints out differently. So the way we get around that is a new parameter expansion, and that's going to be the delete everything before or delete everything after some sort of a match. And that parameter expansion is done with the pound key, shift3, hashtag, octothorpe, whatever you want to call it. I'm going to call it the pound key. But essentially, if we want to delete anything before, we use the pound key. If we want to delete, and then we have to put a pattern after it. If we want to delete anything after our pattern, then we use the %sign. And the way you remember that is that 3 comes before 5, so pound comes before percentage. So when you're deleting before, it's pound, and when you're deleting after, because 5 comes after 3, it's %. So let's see this in action. How do we use this? Well, you tell it, hey, we're going to delete something before. We need to give it a pattern. And essentially, what we're going to do is we're going to use asterisk and /. The asterisk essentially is match any character, no matter what. It's just a wildcard. It'll match anything. And so anything leading up to this / all gets deleted, including the /. So all characters before the / are matched with the pattern and deleted. So what happens when we try to see that in action? Normal execution looks good. / execution looks good. Oops, what happened there? Well, we took off the leading / as we asked it to, but it didn't take off all of it. And that gets back to what we said before about doubling up. Our pattern here is matched against the first occurrence, so anything or nothing matches the star, and then the / gets matched, so it deleted just the leading /. But if we double up and tell it to match all occurrences, you'll see now that we've carved off all of the leading characters that we wanted to remove. So this turns into password gen, this turns into password gen, and this turns into password gen. So that allows us to normalize that value. Now that may not seem like a big deal here, but if later in your script you created a variable called log file, and you wanted to put that log file in the log directory, and let's call it prog name.log. When you call this as password gen, we end up with slash var slash log slash password gen dot log. If you called that dot slash password gen at the command line, you get the dot slash there. If you called this home bashed password gen, so what you see here is all of a sudden the value that gets stored references a directory path that doesn't actually exist. At least not in this case. Maybe it could, but in either event, it's not going where you want it because the way it was called at the command line varied. And so by regulating that and carving it down to just the value we want here, no matter how the user passes this at the command line, we're going to end up with what we want. So that's why this is very, very useful, and that's why I put that right there at the top of the script. So we've referenced the additional parameter expansion there and the additional parameter expansions down here with the plus set. So let's take a second and go back, nano our README, and let's look at two additional things we've talked about, right? And we've talked about parsing option arguments and we've talked about parameter expansion substitution. For this we used getopts, and this is the bash parameter expansion. Replacement or substitution. The getOps syntax was getOps, and our opt string, and our variable. And we use that in our script like this. And of note, if the first character of opt string is colon, getOps uses silent error reporting. And if you want more information, since this is a bash built-in, you can't use the man command. You can run help getOpts for more details. And I'll do that when we exit just to show you. Let's put one other note here for this. Otherwise, getOps will print the relevant error message is, and let's do this. Let's go over here and change this real quick. I'm going to take this out of here. Put that down here. And up here, let's make a note that in this scenario, the user handles the errors. It's a pretty important note, I think, so let's make sure we get that in there. So, parameter expansion. I know we're going to do multiple notes here, so I might as well just get ready. And our examples included var set, and of course we had var unset, and we also talked about var #* curly bracket. And the scenarios if var is set, replace it with set, otherwise empty. Then in the colon minus or dash scenario, if var is unset, replace it with unset, otherwise use the set value. And then additionally we had the #* scenario, and this one, this deletes the file path from var up to and including the last /. And I mentioned we'd go back to this run help get ops. So that's going to be it for our README for today. So we can just go ahead and close that. Clear the screen here real quick. And like I said, since getOps is a built-in, there won't be a man page for it. No manual entries. Of course, how did I know that? Well, I knew it, but you can find out by using the keyword type getOps. You'll sometimes see this, which getOps, which, if you use which with a command like cp, then you get the result of the file path for the cp command. But as you saw for our built-in, there was no file path. So type is a better way to go about that. Type getOps indicates that it's a built-in. Type cp, tells you the file path and that it has hashed that file path to get to it quicker. On anything that is a shell built-in, instead of having a man page for it, you can type in help getOps, and you will get a full screen for this one full of information. Now we're not going to cover the details on this, but you can pipe this into a pager like less, and you'll see at the top there getOps, opstring name, parse option arguments, and all the stuff we talked about and more is covered here. But I just wanted to show you that help command is out there. Go back into our script, and there's just a little bit more I want to do here, and then we'll be done for today. First of all, I mentioned that the opt variable was only going to be used right here, and then we'd be done with it. So what I like to do to indicate that to any potential users in the future is to unset opt here, which is just bash is going to get rid of the variable altogether. That way, again, the user sees that opt, and when they get to this portion of the script, they can realize that it's no longer used past here in the script. Now there's one other thing. And so there's another option that getOps has that we haven't covered, but it's not required in our use, but it's still handy to know, and you will see it if you see other instances of using getOps. And although this is not required in our usage, but it's a good idea, it's good practice to include this anyways. And that is opt-in. Opt-in is a value that when getOps initializes starts out at 1, and for every parameter getOps parses, it increments opt-in by 1. So if it parses the H, getOps is incremented by 1, increments opt-in by 1, and opt-in's value would be 2. If it parses the L, getOps will parse the L, incrementing opt-in to 2, but then it also parses the option passed with it, so then opt-in is incremented to 3. The reason for this is that you can use this opt-in to parse additional arguments on the command line that were not parsed by getOps. It's kind of a commingling of positional parameters and getOps. And the way this is used is we're going to introduce the shift command here. I'll come back to that in a second. Since it starts at 1, we want to take that 1 off there. So we're going to decrement opt-in by 1. And we are telling Bash to shift that value. So if opt-in equaled 4, we would then minus 1 equals 3, which leaves us with shift 3. So that's what's going on here, right? We're doing some math. We need to substitute the value returned from that math back into the shift command, so we have the $sign. But what's going on with shift? Well, let's go back up here. And let's talk about our password gen positional parameters again. And as we've covered, this is how they're stored when using positional parameters. But if we add in getOps and we pass these, this whole thing goes into getOps and becomes part of optargs. Opt and optargs, the way we're using it. So these will all be parsed by getOps. But what if we wanted to pass something like some file name along with this without putting any kind of a flag there for it? Well, opt-in would see the L as 1, arg1 is 2, T is 3, arg2 as 4. Opt-in would equal 4, which in turn would create a shift 3. So what does that mean? If we look at these purely as positional parameters, we would shift all of these values over. I'm sorry, this wouldn't equal 4. It would equal 5 because getOps starts at 1. So let me just walk you through that again since I messed it up. Opt-in initializes at 1. We get to L, that's 2. Arg1 is 3, then 4, then 5. And down below we're doing opt-in minus 1. And that would lead us to a shift of 4. Okay, that's better. So what happens? Well, when we shift 4, first of all, nothing happens to 0. That stays the same. But then all the rest of these parameters are going to move left 4 spaces. 4 shifts, 4 positional parameters. So again, 0 stays the same, but the 1 gets thrown away, the 2 gets thrown away, 3 gets thrown away, 4 gets thrown away, and the 5 becomes 1. So what that leaves us with is, after getOps has parsed everything, some file name, and this is 0, and this is 1. And so you could actually reference some file name without the use of getOps parsing it whatsoever. So let's just see that in action real quick to help out with that explanation. And what we'll do is we're just going to throw some random echo statements in here, right? We're going to echo before getOps. And then we're going to go down here and echo after getOps. And we're just going to stick an exit 88 in here. I just like exit 88 because I know 88 isn't used, and it allows me to make sure we exited where we expect it to. And all I want to do is I want to have the script execute up to this exit 88 line so we can see what happens with getOps when it's called. So bash-n password gen looks good. -L16. Before getOps, $1 is the -L, which makes sense. And then there's nothing for $1 because there's nothing after we shifted. But if we put some file name here, now you see that that $1 was the -L we passed. After getOps is done shifting, we have shifted out everything getOps parsed, and we are left with just the sum file name substituted in for the argument, positional argument number 1. Again, since we're not passing additional arguments to our script without flags, it's not used in our case. It doesn't have any effect on what we're doing. But it is used sometimes, and it's a good practice to just go ahead and put this in your script. So I just like to make sure you've got that in there, and we've covered that as well. So let's just recap here real quick what we did today. We've learned about positional parameters. We've learned about parameter substitution. We've added functions to our script. We saw getOps, and we've generated a more robust script with error handling, with help messages, and with options that can be passed from the command line. In the next version, we're really going to amp up the command line arguments and some of the other concepts and actions in this script. And additionally, we're also going to get away from having to call the script with the bash interpreter. So if we save and exit, Control-O, Control-X, again, we are calling our script currently with that bash interpreter, but when we called CP earlier, we didn't use any kind of interpreter for it. And the same thing can be done with our bash scripts. There's just some changes that need to be made to the file we're working from in order to accomplish that. So that'll be another thing that we cover in the next video. So for now, that's going to be it for today. Again, version 3 is going to add additional features to our script along with some new concepts, and that version will leave us with a fully functional password generation program. If you've enjoyed this video, be sure to like, subscribe, and hit the notification buttons to be notified when new videos come out. Thank you.